In section 13.3, we're now talking about inverse trigonometric functions. So we just call it inverse trig for short. But remember, our regular trig functions are sine, cosine, and tangent. The inverse trig functions are going to be a little bit different, but kind of the same concepts, right? Remember that when I write one of these equations, I first start with the, let me retry that. First start with the trig function here. So an example of a trig function would be maybe sine. Next comes the angle, which we often call theta or capital A or capital B. And then here we have the value, and that might be, 0.5, right? So thinking about this setup, this is always going to be your setup, right? What comes first is the trig function, then you're going to have the angle, which might be a number, right? If you know the angle is 30 degrees, you'd put a 30 here, and then the value is what that function comes out to be. So thinking about this, we know that we use sine, cosine, and tangent, right? These are my trig functions, sine, cosine, and tangent. We use sine, cosine, and tangent whenever we're finding a missing side, right? Think about last section we were setting up these problems. If I had a triangle like this, and we had maybe this angle is, 30 degrees, this side was x and this side was 4, well, I could say that the sine of 30 equals x over 4, right? Because we're looking for a missing side. So in 13.2, we talked about how to find missing sides using sine, cosine, and tangent. But now we're going to talk about how to find missing angles, all right? So my trig functions are sine, cosine, and tangent. Inverse trig functions are the inverse sine, written with that exponent of -1. But again, it doesn't mean sine to the minus first power. It's not like that. It's just inverse sine. Here we have cosine, inverse cosine, and tangent, right? Inverse tangent. So these are called the inverse functions. These are my regular trig functions, okay? And we know that inverse functions undo each other, right? Like, for example, the opposite of multiplication is division. The opposite of adding is subtracting. The opposite of squaring something is taking the square root. The opposite of sine is inverse sine. So these are all types of operations that undo each other. They're like inverse functions, okay? So for example, if I had the sine of something, well, then the inverse sine would undo it and vice versa, okay? So these are kind of interchangeable. Inverse sine will undo the sine, and then sine will undo the inverse sine, all right? So again, like I just kind of mentioned, we use inverse trig when we need to find missing angles. All right, so whenever I'm finding missing angles, I will use inverse trig. Whenever I'm finding missing sides, I will use my regular trig functions, okay? So if I have a right triangle, again, this is just applying to right triangles here, two possible ways to find missing sides. The first way would be using the Pythagorean theorem. Okay, now I'd use the Pythagorean theorem if I already know two sides and I'm looking for a third side. The other way is by using sine, cosine, and tangent. Okay, that's how I would find missing sides in a right triangle, these two methods. For missing angles, well, the first way is that I know that all three angles add up to equal 180 degrees. So if I know two of the angles in the triangle, I can always find that third angle by just adding them all up to 180. And then the other way that I can find missing angles is my inverse trig functions, inverse sine, inverse cosine, and inverse tangent, okay? So if we're looking for missing sides, we're going to use one of these strategies. If we're looking for missing angles, we're going to use one of those strategies. So let's actually talk about how the inverse trig functions work. So here we have, here it says if sine of theta equals 0.217, we're going to find theta to the nearest hundredth. So again, in this problem, I know the value, I'm looking for the angle. So whenever we're looking for the angle here, we're going to have to use inverse trig. So if I set this up where sine of theta equals 0.217, again, we said that to undo the sine, I have to use the inverse sine. So I'm going to take the inverse sine of the left and the inverse sine of the right. What's going to happen is that the inverse sine and the sine cancel out, and that's going to just leave me with my angle theta is equal to the inverse sine of 0.217. Okay, this, you must use your calculator to evaluate this. Okay, so you're going to go to the trig button, and of all your trig functions, you're going to see the sine, cosine, tangent. Underneath that, you should see the inverse sine, inverse cosine, and inverse tangent. So you're going to select the inverse sine, type in 0.217 and hit enter, and you should get a value of 12.53 degrees. Okay, so make sure you're getting that. That's going to be the inverse sine. All right. Let me just double check that. And yes, we do get that answer. Okay. So that's kind of how you just do it. If you're looking for the angle, again, you're going to use the inverse of that value. So if they were asking for if it said cosine of theta, you just use the inverse cosine. If it said tangent of theta, you'd use the inverse tangent. And that's it. And that would tell you the angle measure. So let's try a problem here with a triangle. We're going to find the measures of the two unknown angles in the triangle below. So we don't care about the size, we're just looking for the missing angles. We're going to round to the nearest hundredth. So let's go ahead. Let's first start to find angle A. All right. So if I'm looking for the measure of angle A, I have to think about which trig function I would use. So I know that 7 is the opposite side, and I know that 8 is the hypotenuse. So if I'm thinking about the relationship SOHCAHTOA, sine, cosine, or tangent, I know that I'm going to have to use the sine because the sine compares the opposite side and the hypotenuse. So I'm going to say that the sine of my angle equals opposite over hypotenuse. And now I have this. Well, I want to find the angle. And we said that if I'm going to look for the angle, I have to use inverse. So I'm going to take the sine of A and 7/8. And to undo the sine, I'm going to use the inverse sine. Inverse sine and sine cancel out. And so I'm left with A equals the inverse sine of 7/8. All right. So again, this is to be done on your calculator. If you type this in your calculator and you hit enter, you should get about 61.04 degrees. All right, and that's going to be your value for A. Now, the nice thing about this is that once we know one of my angles, I can, of course, find the other angle. So we're going to be able to find angle C relatively easy now that I know the value of angle A. And we know this because in all triangles, the angles add up to 180. So I know that if I take my 61.04 degrees plus my angle B is 90 degrees, plus the measure of angle C, all of that has to add up to be 180. And so if you solve this for C, you'll find out that the measure of angle C is going to be 28.96 degrees. Okay, so that should be the value that you get for angle C. Okay, now again, it doesn't matter which angle I started with. I could have started with angle A and found angle A, and then add them up to 180 to find C, or I could have done it the other way. I could have tried to find C first, and then once I find C, I can, of course, just quickly evaluate A. All right, but that's going to be how you use that inverse trig function to find those missing angles. Last problem here, we're going to solve the triangle below. Now, when it says to solve the triangle, solving the triangle just means to find all the missing sides and all the missing angles. We're going to round all of our answers to the nearest hundredth. So I want to think about what I still have remaining here. I want to find lowercase z, right? Z is the hypotenuse, so I have to find z. And then I also want to find angle y. I don't know what that angle is, so we got to find the measure of angle y. And I also don't know what x is, so I got to find the measure of angle x. So let's start with side z. And if I'm looking for side z, I know that I already have two sides. And so if I have two sides, I can find the third side by using the Pythagorean theorem. All right, so I'm going to take 6 squared plus 8 squared equals z squared. This is 36 plus 64. And then we get 100 equals z squared. Well, to undo z squared, I have to take the square root. And we know the square root of 100 is just 10. Now, maybe you noticed before you even did this problem that z has to equal 10 because 6, 8, 10 is a Pythagorean triple, right? If I take my 3, 4, 5 Pythagorean triple and multiply everything by 2, I get 6, 8, 10. So we knew the answer was 10 without really having to do any work. So just kind of showing you that knowing the Pythagorean triples do save you quite a bit of time. All right, it is worth memorizing those. So let's go ahead now and let's find the measure of angle y. Now again, I could find y first and then add them up to 180 to find x, or I could do vice versa. I just chose y because I felt like choosing y first, okay? But you get to pick which one you want to do first. So to find angle y, I need to identify what's happening with the 6 and the 8. Now I could use the fact that z is 10, okay? So I kind of have three options here. But when you find that missing side z, it's not always going to be a nice number. So if it's not a nice number, you don't really want to work with any rounded numbers because your answer is going to be off just a little bit. So I always like to work with the initial values that they give me. So I'm going to work with the 6 and the 8. And so in relationship to angle y, we know that 6 is the opposite side. And also in relationship to angle y, 8 is the adjacent side. So if I think about which trig function I want to use, SOHCAHTOA, that means I'm going to want to focus on the tangent because the tangent takes the opposite side and divides it by the adjacent side. Okay, so now I know that the tangent of y is equal to 6 over 8. And then we said that to undo the tangent, I need to take the inverse tangent of both sides. Okay, the inverse tangent and the tangent cancel out. And so we find out that y is equal to the inverse tangent of 6/8. We would go ahead and type that in our calculator and hit enter. And we should find out that we get an answer of about 36.87 degrees. All right, so that's going to be the measure of angle y. And then to find the measure of angle x, we know that I can just add up all three angles in a triangle to equal 180. So I can take my right angle, which is angle z, plus measure of angle y, which is 36.87, and plus my missing angle x, and we're going to put the measure. That's going to equal 180. So if you just subtract these from 180, you should find the measure of angle x, and that means that x is going to be about 53.13 degrees. And so we have now solved this right triangle because I know the values of all the missing sides, and I know the values of all the missing angles. So this is in fact solved. And that is what we're looking at to do in chapter 13.8.